Good afternoon, everyone. Myself, Amit Kumar Gangwar, Assistant Professor at Department of Electronics and Communication Engineering, Government Engineering College, Jhalawar. This is the fourth unit, Timing and Oscillator Circuits. In the previous lecture, we studied unit number third about op-amp IC and its application as an amplifier. Today we will study about oscillators, what is the working principle of oscillator, how oscillator generate waveform, all these things we will going to study in this lecture. Dear student, oscillator are electronic circuits that generate an output signal without necessity of an input signal. It means oscillator don't require any input signal. It can generate the output signal with the power supply given to the op-amp IC. It don't need any specific input at the input terminal. It produces periodic waveform on its output with only DC voltage at an input. As I told you, only power supply given to the input terminal of the given to the IC 741 of op-amp, and it produces the sinusoidal or non-sinusoidal depending on the type of oscillator at the output of the op-amp IC. It converts DC power from DC source to AC power in load. As only power supply given to the op-amp IC, so with the help of power supply which is given to the IC, it produces the periodic waveform at the output terminal. Rectifier converts the AC power to DC power, whereas oscillator converts DC power to AC power, and is equivalent. Output voltage can be either sinusoidal or non-sinusoidal depending on the type of oscillator. There are different types of oscillators which present in the literature which produce either sinusoidal signal or non-sinusoidal signal such as square wave, triangular wave, and sawtooth waves. All types of oscillators are present in the literature. In the oscillators, the difference between the oscillators and amplifier is given here. At an amplifier, there is required negative feedback. Here it is required positive feedback. Here required input signal. Here don't require any input signal. But power supply to the IC is given to both the place. Here also given power supply, biasing supply. Here also given the biasing supply. So for the major difference between the amplifier and oscillator circuit at this point of time is here need of input signal, here don't need input signal, here required negative feedback, here required positive feedback. Other conditions we will study in the coming slides, what other necessary conditions required by any circuit to behave like an oscillator circuit. As I told you in the previous slide that oscillator can be designed as sinusoidal oscillator or non-sinusoidal oscillators. Sinusoidal oscillators are different types of oscillators which are high frequency sinusoidal oscillator, low frequency sinusoidal oscillator. High frequency oscillator are called RF frequency or radio frequency oscillator, that is produced by Hartley oscillator, Colpit oscillator, Clap oscillator, and Crystal oscillator. These four types of oscillator produce radio frequency waves, sine waves. Low frequency oscillator are RC phase shift oscillator, Wien bridge oscillator, and Twin-T oscillator. We will study about Wien bridge oscillator because it is mentioned in your syllabus, and we will study RC phase shift oscillator. In your syllabus, Hartley, Colpit, Clap is not mentioned in your syllabus. Only low frequency oscillator is given in your syllabus. So we will study in detail about low frequency sinusoidal oscillator, RC phase shift, and Wien bridge. Non-sinusoidal oscillator is also given in your syllabus. It can be generated by the multi-vibrator circuits and UJT oscillator. UJT is unijunction transistor oscillator, and multi-vibrator circuit which can be generated different types of waveforms such as square wave, triangular wave, sawtooth wave on the basis of circuit on the basis of circuit be designed. This is generated by 555 timer IC also. 555 timer IC. These are the different types of oscillator with their frequency range. Low frequency or audio frequency oscillator are audio frequency oscillator are Bain bridge oscillator, Bain bridge, and RF oscillator, RC phase shift oscillator. Radio frequency oscillator are the Clap oscillator, Hartley oscillator, Colpit oscillator. All these are 20 kilohertz to 30 megahertz. Very high frequency oscillators works at 30 megahertz to 300 megahertz. Similarly, microwave oscillator works from 3 gigahertz to 30 gigahertz. Microwave oscillator can be produced from the gun diode. Using gun diode, we can produce microwave oscillator. And similarly, millimeter wave oscillators works up to 30 gigahertz to 300 gigahertz. These are the basic amplifier circuit which is given here. So to convert any amplifier to any op-amp, basic op-amp to oscillator, there are two conditions which need to satisfy. First conditions are, which it is also called as Warkhausen criteria, which we will study in the next slide. These two conditions are that mod of A beta should be equal to 1, and second condition is phase shift produced by A and beta will be integral multiple of 360 degree into n. N should be any integer number 1, 0, 1, 2, 3. So these conditions satisfied by any oscillator circuit. These are called as Warkhausen criteria. Warkhausen criteria. KHUSHAN. These are Warkhausen criteria. The magnitude of gain of A and feedback network beta should be equal to 1, and A beta should be 360 integral multiple of 360 degree. These two conditions is required for any circuit works as an oscillator. So it is positive, as I told you in the previous slides. For the oscillators, for any circuit should be oscillator, it must be positive feedback, which is given here. It is positive feedback which is mentioned here. This is feedback element, this is beta feedback network, and this is basic amplifier. This is the amplifier gain A is to amplify the input signal Bi and produce the B times B naught output. Here this is the basic amplifier. Which produces the gain A, that is equal to B naught upon Bi in. So B naught is equal to A times of Bi. This is equation number 1. Second equation we can derive from here. Vi will be Vs, input supply Vs, plus sign, which means plus Vf. Vf is nothing but beta times of B naught. This is equation number 2. Put B naught from equation 1 to equation 1 to equation 2 and rearrange the term. Then you will get. Then you put B naught equal to B naught equal to A times of Bi, and you can compute from these two equations B naught by Bs. Put Bi value from equation 1 to equation 2 and rearrange the term. Then you will get this expression. B naught by Bs is equal to A upon A minus A beta. Just see here in this expression, put Bi value from equation 1 to here, so it becomes B naught by A naught multiply here, and rearrange the term, you will get this expression. Try yourself, it is very easy. So these are, you can get final gain. It is a feedback gain. Which you get from your feedback gain of an oscillator, A upon A beta. So as I told you, Warkhausen criteria must satisfy two conditions. First is phase shift should be integral multiple of 360 degree. So how we get 360 phase shift from this oscillator circuit? For 180 degree phase shift provided by this basic amplifier, 180 degree phase shift provided by this basic amplifier, and remaining 180 degree phase shift provided by this beta network. This is beta network, feedback network. So 180 degree provided by this basic oscillator, and 180 degree provided by this. So 180 plus 180 become 360 degree. So first condition is Barkhausen criteria is satisfied. For the second condition, so first condition is satisfied by here, the 180 degree phase shift is provided by this basic amplifier, and remaining 180 degree provided by the feedback network. So we get 180 plus 180 360 degree phase shift, which is satisfy the first condition of the Barkhausen criteria, either 360 degree or integral multiple of the 360 degree. Second criteria is A mod magnitude of product of open loop gain A and feedback factor beta, the magnitude should be, product of the magnitude should be equal to 1. This is the second condition needed for the Barkhausen criteria to be satisfied. If any circuit which satisfies these two conditions can act as a oscillator, can work as an oscillator circuit. If this condition is not satisfied, it cannot work as any circuit cannot work as an oscillator. So this is Barkhausen criteria. It is very important as examination point of view. If suppose A beta is greater than 1, so it is not produce a sustained oscillation, because after some time it becomes infinite and it will not produce any sustained oscillation like this. Sustained oscillation like constant amplitude and frequency, constant frequency oscillation, it cannot produce if A beta is greater than 1. If any of the two conditions is violated, the circuit cannot behave as an oscillator. Either magnitude of A and beta is greater than 1, or it is not satisfy the phase shift property, it cannot behave as an oscillator. If suppose A beta is less than 1, so it will produce decaying oscillation. It is decaying oscillation. After some time the oscillation becomes 0 and no sustained oscillation can be produced if this condition is violated. But this circuit is also satisfy this condition but not satisfy this condition, still it cannot produce sustained oscillation and circuit cannot behave as an oscillator. If A beta is equal to 1, it can produce sustained oscillation like this. Any sinusoidal signal it can be produced. So these are the basic conditions for any amplifier circuit works as an oscillator. Any basic op-amp IC works as an oscillator. I think it is now clear to all of you basic physics and basic science behind an oscillator circuit. If you face any doubt, feel free to mail me. You can also WhatsApp me at my WhatsApp number. If you face any doubt, I will clear your doubt. And I hope you are seeing the previous lecture which I prepared for unit 3rd. Unit 3rd, op-amp characteristics and op-amp application. Now this is lecture number 3rd on op-amp on oscillator circuits. In the next lecture, we will study the first basic most important oscillator, that is Bain bridge oscillator. It's a low frequency sinusoidal oscillator. Then we will study RC phase shift oscillator. These are also low frequency sinusoidal oscillator. Thank you for today. Thank you. Have a great day.